Okay, let's dive right into this. Welcome to The Explainer, where we are going to treat your Cambridge mathematics exam exactly like high-end professional photography. We're going to find the perfect angle, and we're going to frame your answers to capture absolutely every possible mark in those notoriously tricky speed, distance, and time questions. Picture this. You're sitting in the exam hall. It's a real Cambridge past paper sitting right in front of you. The clock is relentlessly ticking down. The pressure is on. And honestly, I see two types of students completely fail this specific challenge all the time. Let's call them Alex and Sam. So Alex is the overthinker. Alex overloads the paper with raw mathematical facts, dumping literally every formula they've ever learned onto the page with zero actual analysis or structure. And then, on the other hand, we have Sam. Sam rushes, Sam completely misses the subtle command word requirements in the prompt, grabs the very first number they see, and just runs with it. When we look at their past paper answers side by side, it is just an absolute sea of red pen marks from the examiner. But today, right here, we are going to change that narrative. Whether you are taking syllabus 0580, 0606, 4024, 4037, or 4040, this strategy applies. We're going to transition your approach from blurry, unstructured raw data to crisp, top-tier, examiner-pleasing answers that practically guarantee those top grades.
So here is our shot list for today's masterclass. We've got 5 critical sections: framing time and timetables, the core formula lens, adjusting exposure to avoid the base 60 trap, unlocking calculator secrets for time, and finally, visualizing graphs. Let's get right to it.
Section 1. Framing time and timetables. Setting up the perfect shot.
Just as a professional photographer meticulously frames a scene before even thinking about hitting that shutter button, you must first frame your raw data correctly. And in Cambridge mathematics, that starts with a deep, fundamental understanding of exactly how the exam presents time. Notice the direct comparison between the 12-hour and 24-hour clock on screen right now. Cambridge exams rely heavily on the 12-hour clock to completely eliminate the ambiguity of AM and PM formats. They require you to be completely comfortable adding or subtracting 12 hours for afternoon times. A time like 2:30 p.m. becomes 14:30. 11 p.m. becomes 2300. You see, when our rushing student Sam sees 2:30 p.m. in a word problem and has to calculate a 5-hour journey, they might accidentally jump to 7:30 a.m. because they aren't working within that structured 24-hour framework. They lose the mark instantly. You must explicitly convert your times to the 24-hour format as your absolute first step. This gives you a solid, reliable mathematical integer to work with. It prevents those silly, avoidable red pen mistakes that ultimately ruin your final grade.
Okay, we're jumping into our first interactive challenge. I'm putting a 60-second visual timer in your mind right now. Scan this data table. This is an actual flight timetable. The journey takes 11 hours and 20 minutes from London to Johannesburg. Look specifically at Monday's row. Can you extract the core trend here before the time runs out? Look at Monday's departure at 1845. Now, why does it say the arrival is 0525 the next day? If we take 1845 and add that 11 hours and 20-minute flight time, we cross over midnight. 18 plus 11 is 29. 29 hours minus the 24 hours in a full day gives us 5 a.m. the next day. Then we deal with the minutes. 45 minutes plus 20 minutes is 65 minutes. Well, that's exactly 1 hour and 5 minutes. So 5 a.m. plus that 1 hour and 5 minutes becomes 0605. But wait, look closely at the table again. It says 0525. Why the difference? Because this data is testing your ability to read the table directly and look out for things like time zone changes, not just calculate blindly from a starting number. This is what we call the evidence step in our PEL answering structure, which stands for point, evidence, explanation, link. You have to extract the specific data point from the table before applying your explanation. And hey, before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and the bell icon right now.
Section 2, the core formula lens. It is time to start focusing your raw data.
Once your time data is framed and you've safely navigated the time format, you need to apply the right lens to focus those numbers. If the data from the timetable is your evidence, the mathematical formula is your core tool. Now here is where our other student, Alex, completely derails. Remember Alex? Alex is the one who overloads the answer with totally unnecessary facts. Alex sees a command word asking for the speed of a train and suddenly starts writing massive paragraphs about vectors, velocity, and displacement. Look, while it is totally true that in physics, velocity is speed equipped with a specific direction, making it a vector quantity, your Cambridge mathematics exam usually just wants the scalar quantity, pure speed. Do not waste your precious, limited exam time writing about vectors unless the command word explicitly asks for velocity. Find the perfect angle and give the examiner exactly the point they are looking for. Nothing more, nothing less. By simply rearranging the fundamental formula of distance equals speed multiplied by time, you can isolate whichever variable the examiner is actually asking you to find. Let's do a live rewrite of a flawed answer right now. I'm putting 60 seconds on the clock for this transformation. Sam originally wrote this on a past paper. It went 100 kilometers in 2 hours, so it's 50. 0 method marks. None. Why? Because the examiner can't see the thought process. Let's apply our proper Peel framework right now to transform this. First, make your point by stating the formula. Speed equals distance divided by time. Next, provide your evidence straight from the text. Distance equals 100 kilometers, time equals 2 hours. Then, show your explanation with the substitution. Speed equals 100 divided by 2. And finally, link it all back to the final answer with units. Average speed equals 50 kilometers per hour. Boom, done. Those harsh red pen marks just transformed into bright, beautiful green check marks. By simply structuring your answer with the core formula clearly stated, you secure every single method mark available, even if you somehow mess up the final arithmetic under pressure.
Section 3, the base 60 trap. We need to make sure you don't overexpose your answer. Okay, welcome back to our interactive workshop. We're going to do a quick Find the Flaw challenge. I want you to read the question on the screen carefully. If a train journey from Paris to Lyon takes 4.8 hours, does that mean the journey is 4 hours and 80 minutes? Think about it for a second. It is incredibly, overwhelmingly tempting to look at a decimal point in time and just read it like regular money or metric measurements. I mean, 4.8 meters is 4 meters and 80 centimeters, right? $4.80 is $4.80. So our student Sam, rushing as always, immediately writes down 4 hours and 80 minutes. Or maybe they write 4 hours and 8 minutes. But is that mathematically correct? The examiner commentary on this specific error is absolutely brutal every single year. They see this hundreds of times a day, and it instantly costs you the final accuracy mark. So before I reveal the secret to fixing this, stop scrolling, subscribe to our YouTube channel Ace the Exams, at AC Exams IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at AC Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, so back to our 4.8 hours problem. Is it 4 hours and 80 minutes? The answer is absolutely, definitively no. Why? Because of the number beautifully isolated right here on your screen, 60. Time is not based on tens, hundreds, or thousands like our metric system. It is a sexagesimal system. That's just a fancy mathematical term meaning it has 60 as its base number. There are exactly 60 seconds in a minute and exactly 60 minutes in an hour. When your calculator spits out 4.8 after a long calculation, it is speaking to you in base 10 decimals. But the real world of clocks and timetables operates in base 60. You literally cannot directly translate the decimal into minutes without running it through a mathematical conversion. If you forget this golden rule of 60, your final answer will be completely shattered.
So to properly expose the true time, you must separate the whole hours from the decimal. The 4 simply remains 4 hours. That's the easy part. But then you take the decimal portion, the 0.8, and you must multiply it by 60. 0.8 times 60 reveals that the remaining fraction of the hour is actually exactly 48 minutes. So a 480-kilometer journey at 100 kilometers per hour takes exactly 4.8 hours in calculator language, which officially links to a final exam answer of 4 hours and 48 minutes. If a question tells you the train leaves at 08:35, you add the 4 hours first to get 12:35, and then you carefully add the 48 minutes to arrive at exactly 13:23. That, my friends, is exactly how you captured the perfect mark.
Section 4, Calculator Secrets. It's time to master your equipment. But what if I told you that you don't even need to do all that mental gymnastics every single time? Think of your graphic display or scientific calculator as a high-end professional camera body. Most students only shoot in full auto mode, completely ignoring the incredibly powerful pro features built right into the hardware sitting on their desk. Look closely at these specific calculator inputs on the screen. Whether you use a Casio by pressing the OPTN button, that's the options menu, or you're rocking a Texas Instruments device by accessing the apps or angle menu, your calculator actually has a built-in sexagesimal function. It is designed specifically by engineers to translate the base 10 language of pure math into the base 60 language of degrees, minutes, and seconds. Now, in geometry, this is obviously used for calculating angles, but in kinematics and speed distance time problems, degrees translate perfectly to hours, minutes translate directly to minutes, and seconds translate to seconds. Finding this specific menu in your calculator is literally like unlocking a hidden cheat code for your Cambridge exam.
So, the absolutely crucial point here is the workflow. How do you actually use it? First, you simply input your raw decimal into the standard calculation screen, just like our tricky 4.8 hours from the previous challenge. But here's the trick. Do not press equals just yet. Instead, navigate through your device's options until you find the angle or DMS submenu. DMS stands for degrees, minutes, seconds. By selecting this option, you're essentially telling your calculator's brain, hey, treat this decimal as an amount of time and format it for a clock for me. Once you hit execute or enter, the calculator works its absolute magic. It instantly, flawlessly converts the pure decimal to degrees, minutes, and seconds. On the screen, you will literally see 4 degrees, 48 minutes, and 0 seconds, which, as we know, in the context of our speed, distance, and time question, directly translates to a rock-solid 4 hours, 48 minutes, and exactly 0 seconds. No manual multiplying by 60 on the side of your paper, no risking a silly, stressful arithmetic error under the pressure of the ticking clock. You just use your gear correctly, and the green checkmarks practically write themselves. This is a massive, vital piece of our complete mathematics answering system.
Section 5. Visualizing graphs. Reading the big picture. Our final step as analytical exam photographers is to look at the fully developed picture. In mathematics, that is the distance-time graph. This is where we bring together absolutely everything we've learned today to read the big picture. When multiple journeys are plotted on the exact same axes, the shape of the graph gives an incredibly clear visual picture of the movement of each object, provided you know how to read the visual language. Rule number 1 of our master system: if the command word asks for speed from a graph, you must immediately look at the gradient. On a distance-time graph, calculating the steepness or gradient of the line is exactly how you calculate the speed of the object. Think about it logically. Gradient in coordinate geometry is change in y over change in x. On this specific graph, the y-axis is distance and the x-axis is time. So change in y over change in x is literally distance divided by time, which is exactly our core formula for speed. It all connects beautifully. You pick 2 clear, easily readable coordinate points on the line, find the vertical difference, divided by the horizontal difference, and you have your speed.
Rule number 2, application on visuals. A quick scan of the lines immediately tells you the entire story without doing a single bit of math. A slanted straight line represents an object traveling at a constant, steady speed. The steeper the slant, the higher the gradient, which means the faster the speed. Simple as that. On the other hand, a completely horizontal flat line is crucial evidence for your Peel paragraph. It represents a stationary object. The time on the x-axis keeps ticking forward relentlessly, but the distance on the y-axis isn't changing at all. If your distance isn't changing, you aren't moving. Understanding this visual shorthand allows you to instantly extract the right evidence for your written explanation, avoiding the traps that catch students like Alex and Sam.
Let's look at this complex data timeline to pull the whole system together. By tracking timelines on the exact same axes, you can visually determine the entire narrative of the word problem. Car X departs at 7 a.m. at a steep gradient of 60 kilometers per hour. But at 8 a.m., the line goes completely flat. Car X becomes stationary for an entire hour, taking a rest break. Meanwhile, car Y doesn't even leave point A until 9 a.m., but it travels at a steady, unbroken gradient of 50 kilometers per hour. By following both lines across the graph, we see them intersect precisely at 11 a.m. at point B, 100 kilometers away. Even though car X was much faster initially, that horizontal stationary period allowed car Y to catch up. They arrive at the exact same time. This is the complete mathematics answering system in action. To guarantee top marks, you need 3 rules. Number 1, command word decoding. Don't be like Sam, know what they are asking. Number 2, Peel framework application. Point, evidence, explanation, link. And number 3, the time management matrix, understanding base 60 and 24-hour clocks. If you can decode the command word, apply your formula to extract this data, and manage your time formatting, you have mastered the system.
And that brings us to the ultimate philosophy of this explainer. Find the perfect angle, frame your answer to highlight the key evidence. If you remember the base 60 trap, if you leverage your calculator's hidden gear and carefully read those gradients, you will confidently capture every single mark on your next exam. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.